But okay, so here's the agenda this morning. If you haven't had a chance to go get some coffee, go get some coffee. There's some food back there as well if you're hungry. We will take breaks. I like to shoot for a break every hour, so 5-10 minutes, something like that. And if you got to get up and walk out, please help yourself. We are going to have 4 modules here. Generally, we'll have a first one. We're going to talk about, what is AI? What is some of the terminology? It's very catchy, topic these days, and a lot of people are talking about it. And it helps to understand, what do people mean when they talk about, the difference between like machine learning and deep learning. Or what are all these algorithms? So we'll talk about that, give you some show you some of what's out there, kind of an overview of sort of the state of the practice right now. And then our second module, we'll look at some applications for planning and estimation, cost estimating, some pre-construction applications. After lunch, we'll look at some applications for construction administration and management. And then finally, some forensic applications. Specifically, a colleague of mine who ran a lab up in Iowa State. He developed a way to use machine learning to build to automatically build as-built schedules using daily work reports from projects several years ago, and that's really slick little piece of technology. I'm going to show you guys about that. So Dr. David Zhang. He's at Texas A&M now, but he was up at Iowa State. So, and then we'll. I know it says 4:30 here for dismissal. They're closing. They shut the doors here at 4, so we'll be out. Before 4 o'clock today. So we will have lunch around 11:30. So you can just ignore the time zone there. Any questions on that before we move on? All right, so for everyone who doesn't know me, I'm Nils Gransberg. I'm the vice president of Gransberg and Associates. We're a construction engineering consultant here, based out of Norman, Oklahoma. We specialize in capital program development, procurement support, claims, forensic scheduling. Do a lot of claim support, as well as owners advisors. We got several federal clients right now, but we've worked with most of the DOTs in the United States, as well as both internationally here and in the United States. In a former life, I was in the Army Corps of Engineers. Retired from that. Worked in the public sector as a capital projects manager, owner's representative, and I currently also teach as an adjunct professor down at University of Oklahoma. Got Texas on my mind for some reason here. It must be all those Texans that are online here. Just to caveat that, full disclosure, I did go to high school in Lubbock, Texas. So, for all my friends and patriots up here on the other side of the Red River, please don't hold that against me. All right. So any questions or comments? All right. So feel free, throughout this to, if you got a question or an impression or something like that, just let me know. I'm more than happy to stop and talk about anything and drill down to anything you'd like to drill down to. Same thing as, in the breaks or afterwards. Feel free to reach out to me. More than happy to, elaborate on anything maybe we've covered in here, or if there's something that I've alluded to, or if you're looking for a paper or something like that, I'm more than happy to find where those are and share those with you. But that being said, I guess that's enough introductions. Let's just dive right in to what is the artificial intelligence. Now, can everybody see the screen here? Or do we need to dim it a little bit? Or are we good? Okay, good. All right, so to go back in time a little bit, what we talk about when we talk about AI. This is actually is actually a relatively novel technology. This is really still a new technology. It's not as new as a lot of us think it is. We can really trace this back to Alan Turing. He had a paper in 1950 called "Computing and Machine Memory," and he posed a question about it's called the Turing test now, which is to determine whether a computer a computer program could respond to queries from a person, and that those responses, if they would be distinguishable or not from a human response, right? And that was really kind of it's a foundational test when it comes to the theory of artificial intelligence. And Turing was a really prolific guy. He wrote a whole lot of stuff. He helped develop a lot of technology. One note: if you should have a digital copy of these. Anywhere there's this light gray, I've embedded links in the PDFs. So if you want to go and find some of those papers, there's links in here as well. Or there's also web addresses if you want to access any of this stuff on your own. So now, the John McCarthy, he's one of the founding fathers as well, and he has a really good definition for artificial intelligence. In fact, he's one of the he co-authored the paper that coined the term artificial intelligence. He says it's the science and engineering of making intelligent machines, especially intelligent computer programs. And it's related to the similar task of using computers to understand human intelligence. But AI does not have to confine itself to methods that are biologically observable. So one of the interesting features of artificial intelligence really is mirrors in many ways the way that our own intelligence functions, right? The biological intelligence works, the way we think, the way we make decisions. And there's this back and forth really between these two fields of studying human intelligence as well as creating machine intelligence, right? The field, though, is really focused on enhancing problem solving, and that's kind of the one of the underlying themes you'll see throughout the development of AI and over the last 50, 60 years or so. But what it does is we're using these enhanced problem solving algorithms so that we are able to query and utilize very robust data sets, and to be able to extract or glean or identify trends and patterns and information and knowledge that wouldn't otherwise be readily apparent to a human being who is looking at the same thing, as well as significantly reducing the amount of effort and time that goes into having to process or use or draw or extract information or usable data from these large data sets. And as we have continued to expand and technology has grown exponentially, especially in the fields of computer science, with processing speed and storage capacity, cloud computing, and being able to store and readily access, vast amounts of digital information that's held on a cloud system, as opposed to having to have that on your own hard drive or on some kind of physical, on your own computer. That's been really where we've seen a lot of this, really start to grow. So now we consider what we call AI now. Actually, we would call this is considered weak AI, or artificial narrow intelligence. So you'll see this sometimes as an acronym as well, ANI. And weak AI is essentially, it's not sentient, right? It's not self-aware. It's patterned off of our thinking and the way we think, the way we understand intelligence, but it doesn't perfectly mimic that. And really the difference between a weak AI and a strong AI is something that's still, there's a lot of folks who are working on trying to develop it. It's called artificial general intelligence. Artificial general intelligence is the stuff that scares people. You know, you can think of like movies like Terminator and whatnot. You know, we're handing it all over to Skynet, and you know, became self-aware, and then the computers started making robots, and then the robots wanted to come nuke us all, and yada yada yada. Right? That's AGI, and we don't have that yet. We don't. Now there's a lot of back and forth in the field. There's a lot of people who love to talk about it, and you know, some of the stuff you'll see, I think it's pretty common, is folks who are either own companies or lead companies that are engaged with the R&D, you know, developing this stuff or going after it. There's an interesting bias that you'll notice is that most of these people tend to overestimate the ability for them to achieve these kind of technological breakthroughs, as well as the threat that it poses. Because I mean, it's like anything. If you spend all day, you know, up to your eyeballs in this stuff, thinking about just that, not seeing anything else, it's all going to seem much bigger than it actually is. So I'm not nearly as concerned about the you know, the catastrophic effects of AI, especially when it comes to AGI. I don't think AGI is, you know, I mean, maybe I'll be wrong. I'll be fine with being proven wrong on this, but I don't think we're going to see AGI anytime soon. I think that's going to take quite a bit more effort, and really it's just because it's the level of complexity required to be able to program an intelligence to function the way human intelligence does. We're just, you know, we're irreducibly complex biological systems, and trying to replicate an irreducibly complex biological system in a digital, you know, as a digital system that uses different materials, right? We're still functioning on electrical impulses and that sort of thing, but we're talking about the difference between a biological system and silicone, right? So something that's on a silicone diode or something like that. So so that's kind of the you know, where we start at. And if you look at the history of, you know, or the timeline here, right? You know, and this is really about 70 years, right? 70 years or so from the time when the first real intellect started to, you know, put this down on paper and said, hey, what about computing machines? What about computer intelligence, right? You know, 6 years later, we get the term artificial intelligence, right? There's also, if you're a fan of science fiction, there's an explosion of really great science fiction novels that explore these topics in depth, that really kind of start around the 1950s or so and continue on over the next 20 years. You have some really seminal works. Now, in 1967, so 17 years after Alan Turing's paper, Frank Rosenblatt built the first computer that was based upon a neural network. And neural networks are one of the foundational types of programs that allow us to be able to have or generate artificial intelligence. And he built the first computer in 1967 based upon that, and that was the Mark I perceptron, which is also a really fun word. I like the way that sounded. So I was like, yeah, the Mark I perceptron, pretty cool. And over the next 13, 14, 20 years or so, you know, we saw the move from mainframe computers to the personal computer, to the desktop computer, right? Technology got smaller. We were able to shrink things down. We went from using programming with cards and tape, punch cards and that sort of thing, to being able to use you know, keyboard inputs, text, ASCII. And in the 1980s, what we started to see was a development and the widespread adoption of these backpropagation algorithms that are used by neural networks for self-training, and which also I think is interesting too, because we look at AI and go, oh, this is a new thing. We've actually been using, you know, some of these artificial intelligence tools and programs for quite a while now. These aren't all perfectly novel. But so we started to see those get developed in the 80s. And then in the late 90s, we started to have some breakthroughs, some major breakthroughs. So the first one was, really was, I don't know if you all remember the IBM Deep Blue computer. And they had it play the world chess master Gary Kasparov, and it beat him twice. Huge breakthrough, there was, the rending of garments and, gnashing of teeth about, the computers were gonna kill us now that they could beat us at chess. And, here we are 26 years later, and they still haven't. But, they continued to make some of these really big breakthroughs. So in 2011, IBM's Watson beat Ken Jennings and Brad Rutter at Jeopardy. That was a pretty cool one. I remember watching that one on TV. In 2016, the DeepMind developed a program called AlphaGo, and Go is an incredibly complex game, like chess, but much more complexity, much larger game space. And it beat Lee Sedol, who is again world champion at Go, in 5 matches. And then really the last year or so is where we've seen a really widespread public adoption and acknowledgement and understanding of practical applications of artificial intelligence, right? And that's really the big breakthrough has been these large language models. And so like ChatGPT, that program, its adoption is insane. I mean, it was from the time they released GPT-3 until it, and then to the public, and you could get on it. It was, everybody jumped on it. But that's kind of where we're at here today. And at this point in time, is we're starting to see some new models. We're starting to see them work, and they're being able to do some really pretty incredible stuff. LLMs are huge. It's a big breakthrough. And everybody tries to text me or call me when I'm teaching, so sorry about that. Really big breakthroughs in the technology, and so we'll talk a bit here about that. Kind of what are those applications?
Transportation, AI. Yeah, on construction management.
All right, can you hear me now? All right, sorry about that. Somehow that muted me. Okay, so I'm back on. Okay, so what we've seen is a fairly widespread adoption of AI technologies and applications across all sorts of different sectors. And so if you look at this study looked at it, their respondents, they said that they had adopted AI technology or applications or processes in at least one business unit or function was 20% of them in 2017, and in 2022 it's 50%. So 50% of the respondents on here have adopted AI in some form or fashion in their business, and I think we're going to continue to see that grow. People are going to understand kind of some of the benefits to it, how it can be applied. I think where we're at right now is we haven't fully explored all of the potential applications, and there's going to be a lot of opportunity for innovation here over the next several years to be able to find new novel ways that artificial intelligence applications can be used to improve existing processes. And as ways to really be able to increase productivity, quality, you name it, a whole bunch of other stuff. Now, if you look at the top AI process applications, these that were for the response in the study. All right, this is by percentage. The biggest one, around 39%, had robotic process automation. So we're talking about automated manufacturing, automated equipment handling. Computer vision was number 2 at 34%. Computer vision has really grown significantly in its capacities, capabilities, and it's really impressive what we can do with computer vision, AI enhanced computer vision applications these days. Natural language text understanding was number 3. I was around 33%. And so that's being able for a program to understand something that you write into a computer, right? Text prompts. And if you've messed around with ChatGPT at all or any of these other LLMs, that's how they function, right? They function by you writing in a prompt, and it interprets whatever you've written there and attempts to go and use the algorithms that have been trained on these massive amounts of text data, raw data, to generate what you're looking for in a very precise manner. Deep learning is right there with that as well. Deep learning is really a subfield of machine learning, and then also knowledge graphs and digital twins. Digital twins is real interesting. I know, with ASCE, I don't know if anyone here remember ASCE as well. So ASCE has been pushing digital twins for quite a while, and that's essentially BIM, right? Digital twins are building information modeling, BIM, and we're starting to see a lot more adoption of BIM in the transportation sectors, where traditionally it's been really kind of restricted into commercial construction, industrial, those kinds of applications, really the sort of, the building, the vertical projects. But we're starting to see a lot more BIM adoption and application in the horizontal fields as well, in roads and bridges and water, wastewater infrastructure and that sort of thing. So, and digital twin is really just being able to model what we're going to build, and then be able to use that dynamic model to be able to optimize our design as well as manage our projects. And on the backside too, one of the things that I think we're going to start to see a lot more, kind of as we progress over the next few years, and some of these younger folks are coming into the field, is we're going to see, I think, much more adoption of BIM for an operations and maintenance tool as well. So for O&M, I think BIM's potential has been really kind of underutilized, especially in the DOT space. And I think, for being able to see some of these initiatives that DOTs are, rolling out some of the smart technology, BIM applications for that are going to be big, because I can take and embed, I can embed all of my submittals, my quality, QC, QA stuff, my test reports. I can put in my inspections. I can embed images. I can embed inspections. I can do all this stuff into a single model that's actually really readily available. I can use a visual interface and a mouse to go and click on the spot on that thing that I want to find the deal from, and it goes, here we go, right? And it's very intuitive. I don't have to go dig through a bunch of files. I don't have to call somebody up, or I don't have to go down to the archive or whatnot and be able to find this stuff, or hope that somebody's got it on a file folder somewhere on their computer, that I can find these things. So I think we're going to see, and especially with proprietary AI models, the ability to search and query and find documents internally, I think is going to potentially be probably one of the most widespread benefits of AI adoption from a enterprise standpoint, is being able to reduce the amount of administrative workload that it takes to find information, to query and be able to pull up the information you need. Now, if you look at the business case, use case, the top 5, and these top 5 AI use case were, first one was service operations, and this is looking at the decrease in cost that was associated with AI adoption, as well as the revenue increase associated with AI adoption. So, service industry, service operations has reduced costs from where they've used AI by about 45%. It's massive cuts. You know, and we've all had the pleasure of dealing with the AI with AI applications in the service industry. Anytime you call up a large corporation or the hospital or AT&T or somebody like that, and you have to talk to a chatbot, you get a virtual agent on there. You're talking to an AI program, right? Instead of a person. So they don't have to pay somebody to do that now, right? So they don't have to pay employees to sit there and just answer phones. They can have less people answer phones because they can be plussed up, staffed up essentially with virtual agents that help be able to share that workload and handle the mundane, the repeatable, the routine tasks. Product service development. Again, this is another one. This one had the biggest increase in revenue, which was 30% decrease in cost, 70% revenue increase. And this has to do with, I think, manufacturing is also part here on this one. This is like product development. Some of the things we've seen with automated design in like the aerospace industry, where they're able to use AI enhanced design software to recommend the design of optimized aircraft components that minimize the use of material and maximize its strength and durability and are optimized for certain kinds of goals. And we're going to see those things roll out as well here. They're already here in our industry. We're going to see more of that as well. Risk management's another solid one. This one's real near and dear to my heart. You look at risk. Risk is all about being able to quantify or qualify the potential for things to go wrong, or the opposite. They call opportunity risk, for things to go better than expected. And traditionally, when it comes to risk management, we use expert judgment as well as some historical data to be able to associate dollar values with risk and put together contingency and to manage it. Whereas if we have machine learning tools that are able to process large amounts of information and be able to extract trends that would take us hours and hours and hours of digging through and messing with the statistics and stuff, we'll be able to pull trends out and say, oh, hey, on the last 25 or 30 projects, here's what your actual cost of risk for this specific risk is, right? And they can do that in 10 minutes or something like that, right? So being able to do a better job of managing risk also increases our ability to expand capital programs, right? And on the DOT, we're always trying to fix one more road, right? We're always trying to add one more bridge into the program. And these kind of applications help us do a better job of efficiently managing contingency. So we're not tying up money on projects that we don't need it on, right? And then supply chain management as well. So, but good study. You can find that in that link there as well in the top right. Any questions so far? All right. So stop me whenever you want. All right, so we talk about these terms are used kind of interchangeably: machine learning and deep learning, and really they can, for the most part, be used interchangeably. Machine learning is really kind of an umbrella term, right? That refers to any kind of computer program that utilizes neural networks to be able to learn from data. So a neural network is built to mimic essentially how we think, right? How we learn, how our neurons function, right? And it's going between these binary options, yes, no's, right? And being able to come up with and develop knowledge or data based upon that. Now, machine learning relies upon human experts to essentially set what the hierarchy and the models are, to be able to say, okay, here's what's important, here's what's not important. here's how we're gonna organize this, right? And the earliest versions of AI are machine learning programs where there's expert knowledge is used to help kind of set them in place, right? And in many ways, when we look at artificial intelligence, it's really a mirror to look back at ourselves. It's a reflection of how we think. It's a reflection of what we believe and what we how we see the world, right? And it carries a lot of those same biases that we carry as well. So it's something to consider when you're working with this. Now, machine learning, one of the things that really kind of differentiates that between machine learning and deep learning is that machine learning, just in general, not in specific, typically requires structured data. That means that I need to have my data organized. I need to have it labeled. I need to understand what each data point is, what it means, and I need to have that categorized in a way that my algorithm can then go through, and as it processes that information, it's able to understand what is what, right? And it doesn't have to guess or figure it out on its own. Now, deep learning is really a subset of machine learning, and the big difference between just what we would consider machine learning and deep learning is the layers of neural networks that are utilized in the algorithm. And deep learning is typically a algorithm that's comprised of more than 3 layers of neural networks, right? These are multiple layers of neural networks that are looking at information, that are querying it, that are analyzing it, that are making judgments on it, that are sorting and organizing and doing all sorts of things. So, and some of these deep learning models have a lot of layers. I mean, you look at the LLMs, and they're proprietary, but some of these LLMs probably have, somewhere between 10, 20 layers, maybe more than that, of neural networks, which becomes increasingly complex, right? Because the way that they all interact with each other matters as well, because it's not just that one neural network in itself, but it's how all of those neural networks then relate to each other and function together as an ensemble. The cool thing about deep learning is we can use this to do feature extraction on larger data sets that aren't organized. They're unstructured. And really, this is one of the big breakthroughs here, is how we're is learning how to teach or train a machine learning algorithm, or AI algorithm, to be able to look at a bunch of data and then figure out on its own what it means, right? So that uses 2 types of learning, and in any kind of machine learning algorithm, we're going to have a training activity, right? Part of it's going to be training the algorithm to understand what is and what isn't, right? And then we're going to have a test as well. So we're going to test that. So, and one of the functions that we see is commonly used is called a split train test, where when you're developing a machine learning application or an algorithm, you're gonna take your data, you're gonna split some of that data out, you're gonna train your algorithm on that data, and then you're gonna test it on some of that data you've reserved to then validate as to whether or not that model did a good job of learning, right? Or did it make mistakes, right? That's kind of where you get that QA, QC role, that quality control feature of putting together your models. Because if you let a model just go off, right, and you don't test it, you don't validate it, you don't verify it, it can generate all sorts of crazy stuff, and it doesn't know whether it did a good job or not, right? So, but for training, we have 2 types of training. We have supervised learning, and this is where we're using labeled data sets to be able to establish what those hierarchy of features are. So, like, for instance, once on an algorithm I wrote a few years ago, I was training a machine learning algorithm on being able to predict final cost of construction based upon the early estimate, size of the project, duration, and then also the actual durations, final cost, and that sort of thing, right? And so for my supervised training, essentially I had a database of over 250 projects, and I had about 70%, 80% of that was used to train the algorithm. It was like, okay, here's what it looks like, right? This is an estimate. Here's the early estimate. Here's the cost at procurement. Here's final cost, right? And then start to draw these inferences in between them. So, and that's really what you're doing. And then you're taking that out and you're saying, okay, now that you know this, if I give you just one feature, right? Hey, here's my early estimate. What do you think my final cost is going to be, right? And so that's kind of the function of supervised learning there. Now I had a question that says, how does one decide whether to use deep learning neural networks or not? What factors are considered? Really, the deep learning models are that's kind of that's where we're at right now for the most part. And the big difference between using, just a machine learning algorithm versus a deep learning algorithm, it has to do with the application itself. If it's more simple, if it's automated, if it's a smaller data set, it's less complex. I'm not going to want to have to spend the time to develop a deep learning model if I can use a simpler model that'll do well enough. So hopefully that answers that question. But yeah, I mean, because what you got to consider is what's already out there and how much effort and time and money do I have to expend to be able to develop one of these algorithms to do something that I need it to do. So now with unsupervised learning, this is where we're taking an algorithm, right? We're taking a deep learning algorithm and we're saying, okay, this thing keeps muting on me for some reason. Anyhow, if somebody's on there that's messing around with the Teams, please be sure that you don't accidentally mute me on here. I got the feeling that's probably what's happening. Okay, so where were we? Unsupervised learning. Yeah. Okay. So if you've ever had to do any data analysis, right? You know that most of the work comes in is getting the data and making that data useful, right? So if you've ever worked as a cost estimator or something like that, or scheduler, you've got cost data or schedule data, it's really important to make sure that when you bring new data in, that it's organized and it fits in your database, right? So that I don't have to go through and try to figure out what everything means, So that means if I've got a database on projects, I got a project cost database, right? And I've got cost data for different points in the project. I want to have those in the same units, right? The same kind of measurements, So I'm looking at total cost. Total cost needs to have the same definition, right? So what is final cost? Is final cost just what I paid the contractor, or does it also include what I paid the engineer? And does it also include soft costs? If I'm going to have unit costs, what units are those in, right? And so, it's like our statewide bid averages. You see those. Those are really important tools, and to be able to be useful, right? That means that those bid tabs that go into those have to be all already organized, right? So a lot of time goes in to be able to structure that data and make sure it's clean. Unsupervised learning models means I don't have to spend that time. I can query a large database, I can have it pull information and then use it. And I don't have to spend a whole lot of time trying to organize that, clean it, and whatnot. What I do is I've got maybe a couple of different iterations within my model that go through, does feature extraction, then it sorts it, then it does some quality control checks, and then usually I want to have some sort of human interaction just to check, right? And validate that, yeah, it did a good job. It makes, it's doing what I want it to do, right? Before I then move on with it. But unsupervised learning models are incredible because the amount of time that it saves you in being able to use that. It also makes a lot more data available for use that you wouldn't otherwise be able to utilize, right? Anything that's open source. anything I can query over the internet, right? Anything that's on a server or on the cloud that I got access to, I can query that. I can use that data, and I don't have to spend a lot of time going through there and digging through it. All right, so we had another question. It says, you talk about data quality, missing data along the way. How does one know if there's enough data for the type of model one's using? Great question. Actually, you know, when you look at especially construction data is notoriously difficult to get your hands on, especially since most of it's proprietary. You know, you look at cost data, schedule data, unless it's a you know, a public job where that data is shared through a public interface or database, or there's, you know, open records requirements or that kind of stuff. You know, most of your companies, general contractors, aren't going to share data, right? They're not going to share a lot of that data. So when you look at putting together databases of projects, looking to be able to assemble those things, you're always going to have issues with missing data, right? You're always going to have issues with just missing data points. And even if you have access, you know, to public records and that sort of thing, you'll find that a lot of it is either you know, input improperly. Somebody didn't understand how to fill out that field, right? Or there's just holes in it, there's gaps that's missing. And actually, the AI can help be able to fill those gaps and do data imputation. So one of the earlier algorithms was called bootstrapping or bagging, and bootstrapping was a way of using complete data to train a model to understand what missing data should look like, and then generate synthetic data to fill those missing data. Now there's been some refinements on that, and I'll talk about this a little later too, about random forest. Random forest is a ensemble learning model that can be used to help generate synthetic data to be able to fill in those gaps, right? To fill in those missing data points, and ultimately, ideally, you want to replace whatever that synthetic data is with actuals. But if you don't have that, you can still reasonably impute what those data points should be, and have data that you can then use to do analysis. You know, that you can then use to conduct statistical studies and that sort of thing on. So, you know, that's one of the things here that we're seeing more and more applications of. And what's real interesting actually is in healthcare, one of the benefits of synthetic data is that I can do studies without having to expose or have to worry about privacy concerns, because I can generate synthetic data off of medical records and not have anything to do with any real people, right? I can have a machine learning algorithm that goes through digitized records and then creates a synthetic set of data modeled or patterned after those that real data. So lots of applications. And again, like, I feel like we're just kind of sort of just starting to really scratch the surface of what we can do with some of these models. Now, before we take our first break here, I just want to wrap this slide up here. You know, it kind of leads into our next one. And that's looking at generative AI models. And we call these, you'll hear these often referred to as foundational models. And the foundational models are ones where they learn from absolutely massive amounts of raw data, and then generate statistically probable outputs from those input prompts. So, you know, if you look at some of the examples that we've seen here lately, like GPT-4 that's out now. You know, ChatGPT is a foundational model, and it has essentially learned from the entire internet. Interesting thing I heard on a podcast earlier this year from some folks who are developing LLMs is that they've kind of run out of data, training data on the internet. So, you know, as long as we can think you know, that it's like, oh, the internet's endless. Not anymore. These LLMs and these massive machine learning algorithms have used all the data that's out there. So, but But anyways, the thing that's great about some of these is that they're able to learn across multiple domains, right? So I can look at, I don't have to worry about just focusing on one specific type. I don't have to develop a different type of algorithm to access and query different types of data. These can learn across multiple domains. They can use large unstructured, unlabeled data sets, and then be able to extract or extrapolate trends and features and underlying patterns that we wouldn't otherwise be able to see. So, all right, we have one last question here. Was, can you keep some of the real data to verify synthetic data generated by random forest? As an example, that's actually what you have to do. Yeah. So that's part of the split train test function in random forest, is that you're gonna train on, you know, that, yeah, you know, whatever that larger percentage share of your complete data is. So I train my model on complete data, and then it generates generates synthetic data for anything that I've got missing data points on. So where I've got certain levels of data missingness, and then I'm gonna use that, and then I can check that synthetic data and compare that against my real data. So yeah. All right. Well, it's looks like it's 8:55 here. Let's take 10 minutes. Go stretch your legs, drink some coffee. We'll come back here at 5 after. You know, for folks who are joining us online here, if you want to, if you have any questions you'd like to ask over the break, please put them in the chat. I'll respond to those here first when we get back in here. All right. So next we're going to talk just kind of go over, you know, maybe a few of these generative AI applications. Again, we've talked about some of these as well. You know, probably the ones that we're all most familiar with, and maybe are the most frustrating ones, are these customer service chatbots. You know, when you call your bank up and it like keeps making you want to push numbers, and it having you ask questions and say, well, what do you want to do? And you say, well, I want to check my banks, or, you know, my bank account. It says, okay, close bank account, you know, and you're like, no, yeah. So those are very common. We're going to see more and more of those in all sorts of varying different applications. They continue to get better and better. Thank goodness they're getting better. Because if they didn't, you know, I mean, people are going to go postal. But fortunately, these chatbots have improved a lot. They're going to continue to improve with the number of interactions they have. These are learning algorithms. They're going to learn from each interaction. They're going to learn from all the other chatbot interactions too, right? So it's these are self-improving. Smart assistants are also really common ones. So anybody who's got a, you know, Alexa, you know, Amazon Alexa's one, Siri on Apple, right, iPhone. You know, and if I'm not careful, I'll accidentally touch the little button on my watch, and it'll think Siri wants me to ask something, and it'll pop in, right? Those are common ones. Those are some actually pretty early ones that again continue to get better. This one I really like a lot, number 3 here, and that's performing data entry. Anything that's really, you know, mundane. Like mundane tasks are fantastic applications for artificial intelligence, right? Deep learning models. Being able to do these kind of mundane sort of tasks without having to have a person in the loop lets those people do things that need a person to do them, right? It's the same thing as, you know, how we're able to automate in you know, our factories and manufacturing. You know, I don't have to have a person at every spot on my factory line to go, one person to pull this lever, right? Another person to push these levers and cut this thing, right? I can automate that stuff, and then those people can do other tasks that add more value, right? That require more than just pulling a lever, right? So like data entry is a great one. And so you look at some of these applications where we're building standard forms or smart forms, right? Or we have things like you know, daily work reports that are digitized, you know, where we have these digital inputs and stuff, and being able to take and extract some of the stuff and automatically fill it, right? So if I know, that I've got a daily work report on my project, right? I shouldn't have to go in there and manually input the weather, right? I shouldn't have to, because guess what? There's already somebody who's monitoring the weather and knows exactly what the weather is at my job site that I can extract, and I can have a bot go and pull that in. Here's my weather for the day. Boom. Here's my precipitation, right? And the only thing I should have to do is then add any context to it. Here's my comments. Oh, guess what? We had so much rain that, we ended up with mud, right? Or yeah, it sprinkled for a little bit, but we didn't get much more than that, right? And as a way to then add some context to this automated information that's pulled in, right? So being able to automate some of this routine, mundane stuff can really help improve how we use that and the quality of that data. And when I was a young officer in the Army, I learned a really tough lesson, but it was a good one that stuck with me, and it has to do with reporting, right? And if anybody's ever served in the military, you know how bureaucratic it can be. So there's always these reports that are going up and down, right? We got to send up reports. We got these reports. We got these requirements. And the thing I found was, the more things you ask for someone to put into a report, the less likely that they're going to actually do the report or do it properly, right? They're just going to start throwing stuff out there to get it off their plate. So really what you want to do is try to only, keep it down to just exactly what you need and no more, right? The best reports that I can get are from, that I can reliably get from someone else is where I'm only asking them for just the things I want, not any extraneous stuff, right? The thing is, with an automated assistant like this or deep learning model, I can get more data, right? I can have whoever that person is now only has to put in just the things that they absolutely have. I need a human in loop for, right? Hey, my loader operator was drunk today, right? that's why we're a little bit slower here on at the plant being able to crush aggregates. So I couldn't get them off the stockpile fast enough, right? Because my loader operator was drunk. I sent him home. I had to get somebody else out there 2 hours later. I lost 2 hours of production from that, right? That's something that the computer can't tell. But I tell you what, even with sensors on equipment now, you can tell how many feet that thing has traveled or miles it's traveled, how many hours it's run. All those things can be automated, and you can pull that data in and understand it and use it. So automated data entry is fantastic, and a lot of potential there to see this kind of stuff really get applied in novel ways to lighten the administrative load, right? The administrative stuff is the stuff that once you get into any kind of management or leadership positions, that's the stuff that it just eats your time up, and it doesn't have a whole lot of return on investment. So you spend a lot of time going through emails, responding to emails, or sending comments back and forth on stuff, or doing administrative actions. And if I can automate some of those administrative actions, so I don't have to do all of it, and I can just focus on what I need, I got more hours in the day to do things that need my attention, right? And then hopefully I'm actually paying better attention to it and applying more intellect and creativity and effort and that kind of stuff on things that actually matter. So great tools. The search and summarize text documents, great function. If you've ever messed around with any of the GPTs or LLMs, this is a really cool deal. I know Microsoft has launched Copilot is their new AI. It's embedded in Office 365. And one of the features of Copilot is that you can have it embedded in your Outlook as well as Teams, and it can take and summarize the discussions in meetings. It can take and summarize a email chain, back and forth communication, and it can take and analyze that stuff and dump it for you and go, here you go. So you have a 2-hour meeting with a client, right? We're going through the specs on this project. We want to make sure that we've got the right piece of equipment and that things. Here's what you need. Here's what you don't need. Here's what you want. Here's what you don't want. And, these AI models, assistants like, Watson, not Watson, but Copilot's one. I think Zoom also has one as well. But we'll take, and they can then extract from that meeting, right? The people's actual, what they're saying, convert that into text. You can get a transcript of that, and they can summarize a transcript and tell you. You can say, hey, what were the most important deliverables from this meeting? And it'll go, okay, here we go, boom, 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 1, 2, 3, 4, right? You can pull that stuff out. You can process it. You can use it to summarize. Same thing with like reports. If I'm putting a report together on something, right? And I've got a whole bunch of disparate, data or papers, that kind of stuff. I can have it summarize each of those papers. I can have it summarize the results of, whatever these things happen to be. And then that gives me, it takes some of the hours that I have to spend going through there and individually reading, and it can highlight the points where I need to go in and check myself and go, okay, here we go. And the thing to remember with all this stuff is, it's like we were talking about over the break, like this is not finished, right? This gets you like over the hump on a lot of stuff. But you can't assume that whatever these bots or these algorithms or models are spitting back out is 100% accurate, right? You got to verify it, you got to validate it, right? You got to check it. It takes a lot of the drudgery out though. Like writing specs. It's a great one. I can get 80% on writing a performance spec if I tell it what specifically I want to write on. I can reference the codes. I can reference, whatever those constraints are or the application. But I got to go back through and make sure it's right. There's actually an interesting news story this year about a legal firm that used a LLM to write all of its legal documentation for this case. And the brief that was submitted to the court referenced all of these different cases. None of them were real cases. So they hadn't gone back in and done their due diligence to make sure that whatever they had used that chat assistant, or that LLM assistant to do was actually real. Like, hey, go check those actual cases, see if they're real cases. And when they came back, the opposing counsel was like, yeah, none of these cases are real. Where'd you get these cases? Can we see copies of them? And they're like, no. So you gotta make sure that whatever you're getting, right, is still good, right? It's the whole garbage in, garbage out. It's a computer. It's not smart. It's a lot smarter than the old programs, but these are things you can do. Marketing recommendation engines. These are real popular for, and sometimes kind of creepy as well. It's like, can you carry your phone around and you're talking to somebody about, like, oh yeah, I'd love to get one of those trucks, and then boom, all of a sudden you get all these ads for the truck, so those kinds of things. Automated stock trading is interesting as well. There's a lot of this going on now too, where we've got stock trading bots that are either providing recommendations, buy and sell recommendations, or automating it, period. Just going and doing the buying and selling, right, with unsupervised trading. Speech recognition is a big one. I use that all the time. Talk to text. You're driving in the car, and somebody's trying to text you, and you can, it reads it out to you, and then you can read it back. Same thing with, like we're talking about, with like the meeting minutes and stuff. Being able to then take and process anything that's said and convert that into text documents that then can be kept as minutes, can be summarized, and so on and so forth. They can also be use deep learning models to code and debug code. Debugging is actually one I haven't done yet, but I love the idea of it, because that's my least favorite part of writing any code. Is I always got one little syntax thing wrong. It's like I got a lowercase letter, it should have been uppercase, right? Or I got, I switched two letters in a term, and now it broke it. Doesn't work, right? So you can use those to write code and to debug it. Medical biosensors is another one. It's pretty cool. Computer vision is huge, you see computer vision applications really all over the place. And I'll show you some applications here in the afternoon on computer vision being used for monitoring construction progress, as well as site security and documenting work on your project sites using remote cameras, and being able to give commands, automated commands to your cameras that are out monitoring and recording your work, and have them be able to, look at the things you want them to look at, right? Pay attention and record the things you want them to pay attention to. And of course, the last one actually is fascinating. And even though we're not in the healthcare industry, this one's really, really cool, because last year this was a novel application of a deep learning model. They had a deep learning model developed, I believe, in France, and they were looking at developing antibiotics. And antibiotic, if you know anything about antibiotics, developing antibiotics is it's really like, a big game of chance. There's thousands and thousands of different types of fungi and that could potentially be good antibiotics. And being able to identify the ones that work is really, it's like, really truly the needle in the haystack kind of thing. These scientists developed a deep learning model that evaluated various strains of fungi to identify which ones had the highest probability of successful application as antibiotic, and then recommended those strains to be used to further develop. And they were able to develop a novel antibiotic in like 6 months, a new kind of antibiotic, 6 months. These things are it's like years in chance. So this is the kind of stuff you see some of these applications. There's also a professor at OU who developed a machine learning or deep learning model that can look at a mole on your skin and tell you whether it's cancer or not. So now I don't have to go, I can just, take a picture. Oh, hey, it's cancer, right? Oh, it's not cancer, right? But those are the kind of things where, we have the ability to really enhance and reduce the amount of time and effort that things take, right? To be able to have some of this stuff. So anyways, lots of really neat, novel potential applications, really cool stuff that's out there. And I actually had a lot of fun putting this whole thing together because I went way down the rabbit hole. All right, so let's talk about some industry use cases here and some more specifics. So, generative AI is really young, and this actually comes from an article by Gartner. And if anybody knows is into software, Gartner does a lot of they do software reviews on commercial software applications. So this was one they were looking at beyond ChatGPT, future of generative AI for enterprises. And these are some of the things that they identified. They really had 5 big ones that they saw, and as really having a lot of potential. Big pharma was the first one, right, with drug design. Essentially, $1.8 billion go market for the development and sale of drugs, and where a third of that cost is in discovery development, right? So a third of whatever that is, right? So, and if you're already using design drugs within a matter, they've already used it to design drugs really fast, right? So they've, if we can cut out, the tail on bringing it, costing $1 billion to be able to develop a new type of drug, right? I can cut a third of that out, right? It's huge, right? If I can reduce the amount of time it takes from years down to months, or from months down to weeks, it's massive, right? Material science is another really interesting one too, and I think there's going to be some applications we'll see here in the heavy civil field, right, in construction. And this is really being able to develop new types of materials, right? Looking at new combinations of materials, new things like they've used it for helping to develop new polymers, right? Combinations of different material. Constituents materials to be able to make new materials based upon some sort of maximizing or optimizing some kind of physical property within it, right? We can see, I'm sure we're going to see this when it comes to concrete and asphalt and paving, and different sorts of applications for materials. I mean, our industry is commodity driven. It's all about the commodities. That's what drives a lot of the cost. And so if we can get more bang for our buck with the materials we have, or if we're able to optimize those materials, maybe we get extend life cycle on them. If I can add a year to a resurfacing project, if I can resurface, a stretch of I-35, and instead of having to come back in like 8 years, I can come back in 9 years. That marginal improvement's huge, because especially if you look at applying that across, the whole state. So these are the kind of things I think we're going to see. You'll see a lot more of this, and I think it's a very fertile field for research and development. Material science is a big one. Chip design is another one, right? This is an interesting one. I mean, and this has been in the news a lot lately. When it comes to the various logistical problems we've had over the last several years when it comes to just being able to deliver chips, right? Manufacture and deliver them. Chip design is a really specialized, highly proprietary process, but they've been using deep learning models to help optimize chip layouts called floor planning, and being able to say, okay, here's where I need to place all of these little components in my chips, right? Optimal layout. So they can reduce the amount of time it takes to develop it. That means you go to production faster, right? And potentially you have better, newer, more efficient technology being able to be brought to market quicker. Synthetic data for healthcare research. So I talked about this one earlier, and this is nice. I mean, the thing with synthetic data is really cool, is that I can solve privacy issues like without having to do anything other than train a model to generate synthetic data based off of real data, right? And then I don't have to worry about trying to protect everything, right? I can delete all my old data if I need to. It's gone. I got synthetic data. And the synthetic data, if I do a good job of training my model, will be just as useful and just as good as my is that real data, right? Especially the more raw data I have to train that model, the better that model should be. So, and there's also applications for synthetic data in construction and engineering as well. Engineering design, the last one. This was number 5 on there, and this was the one I think we're going to see a lot more. I mean, we already see this with software, CAD software, design software, right? Where there's automation built in, and it's taking out some of that routine kind of, it's like the old AutoCAD where you had to draw every single line. You had to draw absolutely everything. Now we can use libraries, we can use, these sorts of building blocks, families of materials and stuff. We're going to see that a lot more. And in engineering design, this is we're able to optimize, to just run a subroutine on our design software to optimize it, right? BIM's got some great applications for like clash detection and that sort of thing. There was some research. They were doing some research a couple of years back. A colleague of mine in Germany, and he's working on automated aircraft design, where your BIM software lays out your entire aircraft, lays out all of your electronics, all your communications, cables, hydraulics in the optimal configuration, right? So you use the least material, it's got the best likelihood for working right, and it takes a lot of the time out and effort out of doing all that stuff manually, right? So, and we're gonna continue to see this kind of this sort of automation in every new update you get with your design software. You're gonna see this it's gonna show up, and you're like, oh, this is nice. Wow, this is great. Hey, it's like doing earthwork quantity takeoff. Back in the Stone Age, when we used to put on furs and get our spears and go down from into the valley to hunt saber-toothed tiger, and you had your paper plans, and you had your engineer's ruler, and you had a bunch of colored pencils, and you were drawing and coloring and calculating and doing all the takeoff, and now you got a computer program where it's like, oh, here we go. I pulled the survey at Terra model. Here it is. Boom. Here's my takeoff. Cut and fill, done. That kind of stuff. So another one I see also as well as being potentially really useful is with the development of specifications, right? Or being able to apply specifications, codes, and other things like that to our designs, right? To being able to have generative design using being able to reference those existing codes and documents and specifications, and to be able to query them so that it matches up. And this is the kind of thing too, where the more time we spend training these models, the better they'll be. And if we're able to automate some of these design processes, this is going to reduce the amount of QA and QC I got to spend while I'm in design, right? Going and making sure that, hey, we remove this comment, change the dimension from this plan to this detail, right? And we can do some of this, and we can automate some of that QA QC like we do in BIM with clash detection. We do the exact same thing. Hey, oh, by the way, I referenced on here this ASTM for this kind of aggregate, but in my spec, it has a different ASTM. Which one is it, right? And have it be able to red flag those things, go, here you go, right? Which one is it? And automate some of that stuff. So I don't have to go in and, and I'm in the middle of a project and the contractor's like, well, you told me it was this kind, and now you're saying it's this other one. I need a change order, right? So that's the kind of stuff I see being able to use. So have any of y'all used any of this kind of stuff already? You've seen any of this sort of thing? All right. Well, it's coming. I'll tell you what, it'll just show up on your it'll show up on your desktop. And you're like, how did this get here, right? I just updated the program. Here it is. So, all right. So I'd like to talk really about LLMs. I know this has been a really hot one, and kind of understanding what these are and how they work. LLMs have really made a couple of really huge breakthroughs in the last couple of years. Especially if you look at folks like OpenAI. So OpenAI is an interesting company. They're actually started out as a nonprofit, and they have a really weird kind of corporate structure. I don't know if anybody's followed the drama from their the board sacked their founder and CEO and one of their co-founders, and then had to bring them back like a week and a half later after Microsoft had offered them a job to come over and do the same thing for Microsoft. But anyways, OpenAI, the whole point of OpenAI, their goal is they want to develop artificial general intelligence. And this is a way to get along through this. But really the difference between these GPTs, that's what they call their models, right? That's their LLM model. So like between GPT-2 and GPT-3, it was the incredible improvement. And then from GPT-3 to GPT-4, it's like, again, massive change and increasing the quality. They were the way they described some of the earlier ones was like they called it hallucinations, right? And they would have like it would almost like it would generate these sort of like hallucinogenic sort of responses to your text prompts, and it had to work through what was causing it to do this. It's kind of like computer psychosis, but they were able to work through it and get them to now where we're dealing. GPT-3 is the open source, GPT-4 is a proprietary one. And the quality of the output is just really, really impressive. It's almost imperceptibly different. I mean, it's most of it's imperceptibly different from anything a human would generate. I mean, some of the writing is really, really good. Now, one of the things you do see, though, you'll notice is that the writing in ChatGPT tends to be a little flowery, lots of adjectives. It tends to lean towards a creative writing style. So you'll see some of that stuff. You got to be aware of it, especially when if you're going to use it for any kind of professional, writing reports, that sort of thing. You can give it commands to say, hey, reduce, minimize the use of adjectives, right? Write in a direct style, right? Use active voice or passive voice, right? And and it'll do that. So, but anyways, so the thing behind LLM is it's a model that is trained on language, and it's developed to understand and precisely interpret natural human language. And it's trained on just an absolutely massive amount of data, lots and lots and lots and lots of data, right? Open source data, proprietary data, talking about, text, video, audio, you name it, right? all sorts of different types of modes, different domains, uh, um, professional writing, creative writing, informal writing, you know, Twitter posts, feed posts, you name it, right? So and it uses you have to have this massive amount of data for it to work. Otherwise, it just doesn't work, especially when it comes to nuance, right? Because like any the culture of any people is wrapped up in its language, and the way a people thinks is reflected very clearly in how they talk and what they speak and how they describe the world around them. And that's one of the limitations of LLMs is most of the LLMs are based on one single language. That's English for the most part, right? They're English language LLMs. So if you're in America, that's great. No big deal. We speak English, right? If you're not an American, it's a little more limited, right? Especially if you're trying to have it in a smaller language where there's not as much just raw data out there for it to train on, right? So they rely on natural language input, and then it generates responsive outputs. And you can, the whole point here is the goal here, and this goes back to the old Turing test, right? I want this to be indistinguishable from what a regular human being who's competent, who would be able to write this or do this on their own, would be able to produce, right? So that's the point here, is it needs to be for very high quality. It needs to be indistinguishable from anything a real person, a biological person would be able to create. So it's used to develop specific kinds of content, and you can also use it to do things like conducting analysis on large amounts of data. And it comes to language, we have different types of languages, right? Code is a great one. Computer code, fantastic. It's a language. It has its rules, it has its syntax, its grammar, right? Here's what this means, here's what that means. And actually, it's a lot clearer than a natural human language, right? Because there's a lot more variation. Look at things like irregular conjugation of verbs. Language like Italian that has over 100 irregularly conjugated verbs. Where there's a rule you follow, but you ignore it for like 100 of them, right? Or like English, which is a a mutt language of sorts. That's a mashup of old Germanic Angle, French, Norman French from the around the thousands, AD 1000, plus Gaelic, plus all the other loan words from any other language that the Brits, from a country the Brits happened to to conquer and incorporate into their empire. So we have all of these kinds of variations. Like in English, we've got two words for almost everything. You've got like cow and beef. In German, cow is Kühe. In French, cow is Bœuf, right? So you have these two words for the almost everything. So that's the thing is, these LLMs can understand what those are. They can also be able to understand how they're used, be able to learn about the contextual meaning, right, that goes in behind them. And that really the idea is to be able to be very specific. And what that limitation is, the real limitation is really on the data for that specific language. So I think there's going to be some interesting ones where we're going to see development, especially where we have different alphabets or different types of written communication. Big difference between Latin script and Mandarin, right? Mandarin characters or kanji for that matter, right? Totally different style, or way of communicating information. So which means that those LLMs are going to be trained slightly different on each of those different kinds of languages. Now, these are some operational ones. There's more than this, but these are kind of the ones that you may see the most. GPT is the biggest one out there. It's the most talked about in the media, right? Because they made it open. They gave everybody the opportunity to use it for free, which is brilliant, if you ask me. It's just like how Bluebeam did the same thing, with Bluebeam Review. They made it free for anyone who was in college to use Bluebeam Review, right? So everybody in college learned how to use Bluebeam, and then when they showed up at work, they're like, "I need Bluebeam. This is what I need," right? Brilliant. So, but they're definitely leading generative AI bot. GPT-4 was released this year, And this is the first LLM in the world that could process both text and images. So we talk about multi-domain capabilities. There's an interesting one funded by the French government called Bloom. It's actually multilingual, and it's an open access science LLM. So it's focused on primarily research, right? Scientific applications. There's another one this is a private one called Claude. It's available in the US and the UK. It's a personal assistant AI bot. And it helps with, text summarization, coding. It's got specializes in like creative writing, but it kind of works as a digital personal assistant, right? Tracking your meetings and stuff, responding to emails, doing, summarizing meeting notes or research, helping with writing. And then the last one here on this one is Orca, and this one is one of Microsoft's LLMs. They have a few. This was trained on 13 billion parameters. So you talk about the size of the data. That's just the parameters. That's not the data points itself. So there's 13 billion parameters, right? If a model I built to try to predict construction cost had 6 parameters in it, right? 13 billion, so huge. This one is actually on par with GPT-4, which is OpenAI's latest one as well, too. So, now, if we look at applications in construction, this actually comes from a paper here. That was just published by ASCE, I think a month ago, and it was looking at some of these applications just in construction engineering. And on the left here, we've got these are all machine learning applications that are currently being used in construction. Clash management's a big one. This one's not new either. So if you've ever used any BIM software, clash detection is a really nice feature. Especially if you have a very tight site, or if you're working in an urban area, right? And I've got a trench box I got to fit all of these utilities in, right? And I can put them all in there. I can tell them how big everything needs to be, and then I can see if it fits, right? Or I may have to, or I'll look at, okay, hey, guess what? I've got this municipal water line going through a sanitary sewer. Hey, that's not going to work, right? No one's going to let me build that. So clash management's a good one. Contracts is another one. This is another interesting one with contracts, and this is with there's been some work on in the private industry on blockchain contracts. Machine learning applications are also in generating standard form contracts, as well as doing contract analysis, right? And being able to identify critical clauses, stuff that are potential showstoppers. Looking at the language, quality languages, and if there's any conflicting clauses or ambiguities, right? Being able to do ambiguity detection, lovely thing. We're using it in cost engineering, construction, with construction costs or with construction documents, talking about automated construction documents, seeing that on some of these, especially cloud-based services, like Procore and HDSS. They're using machine learning algorithms on there. Equipment management's another one. So seeing a lot more applications in the heavy equipment field. We've been using sensors and GPS enabled equipment for a long time now. I mean, it's pretty mature. I mean, there's it's almost kind of rare to go into a big project and find a grader that doesn't have a couple of GPS deals hooked up on each side of the blade. Being able to use things like optimizing your cut, angle your cut. Being able to track your usage. Track your hours. Understand. What my production is. It's used in labor as well. So monitoring is another big one here, and we'll talk more about that here today. In construction monitoring and inspection, planning and scheduling too. You look at some of these applications where being able to develop, automate cost estimates and construction schedules, early schedules. Same thing with optimized work sequencing, right? So I can, if I've got a complex, complex site, or I'm working on I-35 down there south of Norman, and I got to keep keep lanes open the entire time, and I got some complex traffic control. I can optimize my schedule based upon my traffic control plan, right? Say, hey, here's how we're going to lay this out so that we can make sure that we keep everything open for as long as we can, right? We minimize delay, so we can optimize off of those things. Same thing with risk management, construction safety, waste as well. Risk management's a big one. Looking at being able to use data-driven analytics and be able to generate, credible ranges of value when it comes to doing things like contingency management, and mitigating risks, planning for risks, and then mitigating them. And this is a list of the algorithms, and I'm not going to go through all these, but these are some of the names you'll see, and I'll point a few out. So fuzzy logic is actually a pretty old one. This was my first introduction to AI, was with fuzzy logic. I fell into a position right after high school, working as a research assistant at a lab in the University of Stuttgart in Germany, and we were building we were doing research on using fuzzy logic to be able to train a very, very simple robot on going through a maze. And it was a very simple robot. It had two bumper sensors on it, and it had an optical sensor. And the maze was big, and we had a light at the end of it, and the little robot would go in and try to find the light, and then it'd drive towards it. And if it bumped into a wall, it had a little routine. It'd back up, it turned so many radians, and then it'd go again, right? And we were using pi theorem and fuzzy logic for it to improve every time it went through that maze. It would get a little better, right? It'd make a few less bumps, it'd take less time, that sort of thing. So that was my first experience with it. Fuzzy logic is it has been around for quite a while. Random forest, this is another one that you see a lot of. This is actually a ensemble machine learning algorithm or deep learning algorithm, and it's a fantastic tool. And if you can program in Python, or someone who can, Random Forest has its own library set up on there, so it's real easy to use. I don't have to do anything with it other than be able to download it, apply it, and make it do what I want it to do. Genetic algorithms, these are ones that are based on essentially like how genetic replication, right? Different types of neural networks. Decision trees are very common. So actually Random Forest it uses decision trees, and some of these are embedded in other ones, right? We call ensemble algorithms. Yeah. So, and then of course we've got some things like various regressions. Logistic regression is another one, and ANNs, so artificial neural networks. So these ones we see quite a bit of. So, all right. Well, that's the end of our first module here. Let's break, and we'll come back here after at the top of the hour, and we'll get started on looking at some applications in planning, estimating, and pre-construction, and then take us up into lunch, right, around 11:30. So hopefully we should be able to get done with this second module here before lunch. So let's come back here at 10 o'clock Central.